Alright, hell yeah. So I made the problem. Check it out. So this thing's got a point of equilibrium. We made sure everything was crispy. We got a 90-degree angle. We got 60 degrees there. You can check that out. And then we got 30 degrees right there. Now the other aspect of this problem is they say this wheel is 2W. Well, we just made it 2 wheels. Over here is 1W, and the weight of the rod is half a W. And at the end of this video, I'm going to show you that we measured everything crisp. So, booyah, let's check it out. So if I push up on this, it has a restoring force back, and the angle, that was the tricky thing, because in the back of the book, they said this angle was going to be 42 degrees. Well, it happens to be 13.9. Now, honestly, I get about 12 degrees, but seriously, everything is just super crisp, so we don't have too much air there. Now, the answer in the back of the book says the angle is going to be 42 degrees, so where the hell do they get that? Well, probably putting the two wheels over there, the 2W, and then the 1W on this side. And then, hell yeah, we'll come in here and measure this. And for sure, that looks like 42 degrees right on. And so if you do the equations this way, you get 42.2. But that was just, I spent 7 hours just because the answer in the back of the book was wrong. I was scratching my head just making sure. But check this out. So if I push on this, hell yeah, I got a restoring force. And then if I go the other way too, you know what I mean? It's got a restoring force back. Now some of these, seeing is believing, you know what I mean? Even just putting this over here, you're just like, well, is this heavy? Hell yeah, it's heavy, and but it seems like it wants to go down, but in this case, this one is a little bit higher, where over here, hell yeah, this is heavy, and it's just dragging this thing down. So over here, for sure, it's lower, but yeah, just surprisingly, over here, it's not. Because if I have this on a flat, and then this is pulling itself down, this is just going to pull right off. So that's kind of the theory of what's going on, but this isn't flat, it's sloped down. Alright, hell yeah, let's talk about why I'm maybe getting 12 degrees, because this is a little bit steeper, and let's talk about the driving forces of this. Because what do you think if I lift this up and make it flat? Like I said, it's just going to shoot off, because we have a force pulling it that way. So if I make this flat, hell yeah, it just wants to shoot off. And then if I make this steeper, well hell yeah, it's going to balance itself out. So if this is that 30 degrees, let's do it one more time just so you can see it subtly. If I start to raise this slope, well hell yeah, this thing is more like on a level, and this force is just driving it off. Where if I do this, make it steeper, well hell yeah, this is pulling it down. Alright, hell yeah. So what we're going to do is we're going to take this problem and make a simpler problem. We've got twice as much mass here as over here. So let's take those masses and connect them to a string up over a pulley. Let's say they're just kind of hanging out in free space. This one's heavier, so the whole system's going to go like this. That makes sense. But now we're going to introduce a slope. Easiest thing to do is just take this mass and then put a flat surface underneath it. This one's still hanging out in space. Now what's going to happen? Well, this one's still heavier. Nothing's going to happen. So at a certain point, we can tilt this angle up. Let's say it's just totally vertical. Now we're just back to this one pulling down and this one going up. So there's going to be a certain angle there where we actually do make some motion down, where this one goes down, and in that case it's got to roll down the slope. So there's going to be in that problem, there's going to be some sort of angle there. Well, that starts to roll down. So that would be a simpler problem. So not knowing anything about normal forces or forces of gravity and in what direction they apply, that's just kind of an intuitive way to get a feel for a problem. Hell yeah.
Alright, hell yeah. So we set up this experiment. It's not as analogous as I thought. So this weighs twice as much as the weight in this bucket. So this thing just wants to drop to the ground. What we can do is we can put this table underneath this twice as much wheeled thing, and we can increase the angle. But when we increase the angle, it does start to roll. It reaches equilibrium, but it's because this angle forms in the rope. So what we're going to do is we're going to make kind of a steep angle, and then what happens when we remove some bolts from this bucket? If we do that, it wants to slide forward. So we're going to put those bolts back in, and if we take these out, but we don't want it to slide forward, I got to remove these bolts and then slack this angle. And then that's the other thing. If if I take this at this angle and then slacken the angle, it wants to roll back. So then there's going to be, if I take out these bolts and then slack the angle, I can still maintain that equilibrium. So, you know what I mean? Totally not analogous, but it is useful to do another experiment that's similar. Hell yeah. All right, hell yeah. We got all our components dialed in. So we have one wheel. One wheel weighs 135. So half of that, half of 100 is 50, half of 30 is 15. That would be 65. So we're going to have 67.25. So hell yeah, we got 67. That's going to be half the weight of a wheel. A wheel weighs W, this weighs half W. If this weighed 135, this got to weigh 2. So it's going to be 270. So this should be 270. And it was just kind of cool getting this all dialed in. It did say 270 earlier, close enough. And hell yeah. So, all right, booyah. Super fun. And let's get this thing going. Hell yeah.